Hey there, and welcome. We're about to go way beyond the textbook, to explore the massive and honestly pretty surprising world of careers that a physics degree can open up for you. Because it's so much more than just theory. It's about how this stuff actually works in the real world.
Go on, be honest. When you picture a physicist, what comes to mind? For a lot of us, I bet it's that classic image, right? Someone kind of isolated in a lab coat, standing in front of this giant blackboard that's just covered in ridiculously complex equations. And yeah, that's a classic stereotype, but it's only a tiny, tiny piece of the real story.
The reality? Physics isn't just a bunch of abstract ideas. It's the literal blueprint for how our world works and how our future is going to be built. So today, we're going to see how that blueprint becomes a launchpad for this incredible variety of hands-on, super high-impact careers that build, power, and even heal our world.
So where do we start? Well, the most obvious place to see physics in action is, it's everywhere you look. It's in engineering. The very society we live in, the buildings, the roads, the power, it's all built on the fundamental laws of physics.
I mean, just look at this. Every single one of these fields is just physics put into practice. Electrical engineering, that's electromagnetism brought to life to power your home. When a civil engineer designs a bridge, they're using basic Newtonian physics to figure out every single force and stress to make sure that thing doesn't fall down. A mechanical engineer building a jet engine, that's all about the laws of thermodynamics. And the phone you're holding, it works because telecom engineers totally mastered the physics of radio waves. It's amazing.
Okay, so if that's the world physics has already built, where is it taking us next? Let's switch gears and look at how physics is literally inventing the future. It is the engine for cutting-edge innovation.
And this slide just shows two massive frontiers where this is happening. The computer or phone you're watching this on right now, it only exists because physicists first cracked the code on the quantum mechanics of semiconductors. That laid the groundwork for every single microchip. And on the flip side, you've got physicists tackling one of the biggest challenges we face, the green revolution. Designing more efficient solar panels? That's a deep dive into quantum physics and material science. Building those enormous wind turbines? That's a masterclass in the physics of fluid dynamics and how to convert energy.
Now here's a really crucial point. Physics isn't just about inanimate objects and machines and power grids. Its principles actually extend to understanding life itself, our planet, and our place in the cosmos. It gets deeply personal.
And here is a perfect example: medical physics. This is a field where physicists are literally working side by side with doctors in hospitals. They are the experts who get the incredibly complex physics behind all this life-saving diagnostic tech. So next time you hear about someone getting an MRI, remember there's a medical physicist who understands the deep principles of nuclear magnetic resonance that let us see inside the human body without making a single cut. It's incredible stuff.
And this whole idea of using physics to see what's invisible, it extends everywhere. Radiologists use the physics of radiation to not just diagnose, but to precisely target and treat diseases like cancer. Meteorologists are applying the physics of fluid dynamics to our entire atmosphere to predict the weather and model our changing climate. And geophysicists, they use the physics of seismic waves to map out the very core of our planet.
And of course, there's this one. When we talk about applying physics to the universe around us, what could possibly be a more direct application than becoming an astronaut? It's a career that is fundamentally 100% built on a deep understanding of motion, gravity, and the cosmos. The sky is, quite literally, not the limit.
So we've seen all these amazing applications, right? From building bridges to exploring space. But what fuels all this innovation? Where does it all come from? Well, it all circles back to two absolutely foundational paths. The core of research and education that drives every single discovery.
This right here is the engine room. You have researchers in places like CERN or NASA on the absolute front lines, running experiments and pushing the boundaries of what we even know is possible. And then, just as important, you've got the teachers and the lecturers who take all that incredible knowledge and ignite that spark of curiosity in the next generation. That's the spark that leads to all the careers we just talked about. One group creates the knowledge, and the other makes sure it lives on and grows.
So when you zoom out and look at the big picture, the message is pretty clear. Physics is really the ultimate toolkit for anyone who's curious. It all starts with that basic desire to understand how things work, from the tiniest atom to the biggest galaxy. And that understanding becomes the blueprint for basically every piece of technology we rely on. And because of that amazing link between knowing and creating, a physics background doesn't just open one door, it hands you the keys to a whole universe of career paths.
So, we'll end with this thought. If physics really is the key to understanding the rules of our universe, then the question isn't just about what careers are possible. The real question is, what problem will you solve? What will you discover? What will you unlock?